What up, team? Welcome back to another video. This one, we're going to be continuing from the last one, looking at what's going to be on your final. The last two components of the final are going to be a composition of functions as well as factoring. So this video will serve as more of the composition of functions, as there are more components to it that we need to look through. So hopefully it's a quick one. Let's get right to it. So we're going to cross over all of the work that we did from the last video, and then come all the way down here, and then we're going to look at some composition of functions. Now, as we spoke in class, we looked at the composition of functions, and specifically at this word composition, and really just said this is a fancy way of saying evaluating a function with a function. And there's two components to composition of functions that we're going to look at. And in order to look at both of them, we're going to need some examples. So here we'll see that we have an f of x and a g of x. And we'll say, for the sake of this video, f of x will equal 3x squared minus 4x. And then g of x will make it a little bit different. We'll just say it's x to the third power. X squared, we'll say it's x squared. Minus 3. Okay, so we have a couple different things here, and we're going to be doing a couple different pieces of the composition of functions. Now, there's two ways to essentially address the composition of functions. And the two ways that I've introduced is one, composition of functions, and then we're going to evaluate it at a certain point. So we're going to evaluate at x equals something. And then the second one is more of a general composition of functions. And so let's take a look at what I mean by this in both cases. We're going to start off by just doing the evaluation piece of the composition of functions, and what those will look like is this. So I'm going to do part A. Let's say we have f of g of 2. As you see, there's a numeric value in the middle here, which is 2, which means we are going to follow a sequence in order for us to solve this. Because we still deal with the same order of operations, it's always nice for us to start whatever's on the inside of the set of parentheses. So the first set of parentheses that we see around f of x will tell us that g of 2 is on the inside. So this means that first we need to evaluate g of x at x equals 2. Hence, this is g of 2. Then, whatever we get for that, so g of 2 will equal some value. That means that then we need to evaluate f of x at x equals whatever that value is that we just got for g of 2. So it's almost like we're plugging in 2 into g of x, and then whatever that answer is, we're going to plug into f of x. So in order to start this, let's start here. We'll start with g of 2. And so I'm going to just use some different colors so that way we can see it a little bit better. So you have this, which means first we're going to evaluate the inside, which is g of 2. And so in order for us to begin with this evaluation piece of g of 2, we got to know what we're dealing with in terms of g. And so in this case, we're going to be plugging in g of 2, or 2 into g of x. So if g of x equals x squared minus 3, then this means that we're going to take g and now plug in 2, evaluate that, and see what we get. And so just like the other videos that you've seen, every time we're evaluating something at a specific value or a specific point, I really like to put a set of parentheses down so that way we can really see what we're actually plugging in and what we're doing. And so in this case, we're plugging in 2 for x, and then I'm going to simplify this whole thing. So we'll get g of 2 equals, we get 2 squared here, which is 2 times 2, which we get an answer of 4, minus 3, which means g of 2 gives me an answer of 1. So that's this first piece up here. Check, check. Evaluate g of x at x equals 2. Great. The next piece of this is going to be, now we're going to take that answer and we're going to plug it in to f of x. So f of x is going to equal another function up here. So we have 3x squared minus 4x. So f of x equals 3x squared minus 4x. And instead of this x value, we're going to plug in the value g of 2. Now, this is where some students get stuck. This step here, f of g of 2, is going to be the same as f of whatever that g of 2 equals. And so in this case, we solved that, and that equals 1. So we're essentially plugging in 1 into this f of x equation or function. So I'm going to come up here, I'm going to rewrite this. We have f of x again equals 3x squared minus 4x. And we'll solve this out. F of something, we're going to plug in a value. And everywhere we see the x term, I like to put a set of parentheses. And then we know now that that set of parentheses is going to contain a value of 1. Because g of 2 is equal to 1. So we could simplify. We get f of 1 equals 3 times 1 squared, which is still 1, minus 4 times 1 is 4, which means f of 1 equals 3 minus 4, which means f of 1 equals negative 1. Now, we're not done yet because this looks nice and all, but our official answer would tell us that f of g of 2 is equal to negative 1. Okay. So there's a quick example of how to do a composition of functions. A couple of the problems that you'll see on this final will be like this, and you'll be able to navigate through by plugging in and evaluating. Okay. Now, the next piece of this is going to be using the same functions, but now looking at the general composition of functions. So we're going to do another example here, and this one is going to be, let's say, f of g of x. Just so it looks kind of similar to the very first one that we did over here. And this time it's going to be f of g of x, which means we do not have a specific value. We are not evaluating at a certain value or at a certain point, which means we need to find the general composition of functions, which means I'm going to take this g of x, this whole thing, and I'm just going to plug it straight into f of x. So let's see what that looks like. So I'm going to come down here. Because f of x is going to be our primary function here, we're going to do f of x equals 3x squared minus 4x. And we want to find f of g of x. Now, just like we did before, just like we did down here in this example, this little piece down here, let's define what that means for us. So in this problem, you will see that g of x is actually equal to a certain function. So this is the same as plugging in f of whatever g of x is equal to. And in this case, g of x is equal to x squared minus 3. So for this function, f of x, we're going to be plugging in this whole other function. And so that sounds confusing, but treat it as though that x squared minus 3 is already just a number. So when we come in here and we go to plug it into this function, what we're actually going to be doing is taking f of x, making space like we've done before, and in the step down here before, when we actually plugged in a number, in this step, we're just plugging in that entire function. And so at first, this may look a little daunting or nerve-wracking or scary, but rest assured, it's the same thing as plugging in a number. It's just adding a couple more terms. So x squared minus 3, x squared minus 3. So we're taking this f of x value. We're removing the x term, and as our input instead, we're putting in g of x. And then we're going to be putting in g of x everywhere we see this blank space, or we see this input value that we originally had for x. Okay. So then you can simplify. This is the same as f of x squared minus 3, which equals 3 times. I'm going to expand this just so we can see what's actually happening. We had x squared minus 3 2 times x squared minus 3 minus 4 times x squared minus 3. So this piece is going to get some students a little bit confused. You need to expand first before you start multiplying things out. Just like we did before, we have some sort of PEMDAS that we need to keep in mind, right? So multiplication and division are going to come after the exponents and expanding. So we got to expand that first, then we can start multiplying it out. So we'll have f of x squared minus 3 equals 3 times. Now in this step, it's going to look a little bit different than what we've done before. So I'm going to zoom in here so I can show you. I'm going to take every single term in the first set of parentheses, and I'm going to multiply it with every single term in the second set of parentheses. We've discussed this as the foiling method, first, outer, inner, last, but really it's just distribution, right? Foiling is distribution. So in this case, I'll get x squared times x squared, which means I'll get x to the 4th power. And then I get x squared times negative 3, so I get negative 3x squared. I'll get negative 3 times x squared, negative 3x squared again. Now I'm in the orange region. And then I get negative 3 and negative 3, which is positive 9. So here, those are the two blue terms from the distribution, and here are the two orange terms from the distribution. Okay. I can also distribute this last little piece, negative 4, into both terms, which means I'll get negative 4 times x squared, negative 4x squared, and then negative 4 times negative 3, positive 12. And then from here, you can start reducing. So I get this equals 3 times x to the 4th power, negative 3x squared. Negative 3x squared is negative 6x squared, plus 9, minus 4x squared plus 12. And then, yes, you're going to distribute again, because now the 3 is out in front. We got to make sure the 3 gets applied to everything, which means we'll get f of x squared minus 3 equals 3x to the 4th power minus 18x squared. 3 times 9 is plus 27. Because I distributed everything, I don't need the parentheses anymore. Minus 4x squared plus 12. Okay. And then in my final step here, I'll go ahead and combine like terms. I get 3x to the 4th power, and then I have this negative 18x squared, and then negative 4x squared, negative 22x squared, and then I have 27 and 12, which is plus 39. Okay, and so yes, it looks like there's a lot of steps, and most of you will be able to simplify the steps as fast as you can, so you don't need to actually write it all out like this. So I'll show you what that looks like in a second. Okay. And then the more correct answer is that f of g of x is going to equal 3x to the 4th power minus 22x squared plus 39. And there you have it. The composition of functions in the general form without evaluating. Okay. So let's review some of this stuff, each of these steps really quick, and talk about what we did. So this is perhaps the most important step, is understanding what to plug in, right? What to plug in. Some students are going to overlook that and then have some troubles as they move forward. And then actually transitioning into actually plugging it in. And in this specific step, you're not simplifying yet, because you just want to plug it in so that way you know what you're doing. Then you have a little bit of expansion. From the exponents, from the squared exponent. And then you have the actual act of distributing. And then you're doing it again. And then ultimately you're actually simplifying to get your answer. Okay. So that's a quick way of doing the composition of functions. If you look onto our Google Classroom, you'll see an assignment that has a bunch of examples like this, so that way you can get some good practice in. And so if you need any help going through any of that, let me know. But for now, here is your video on the composition of functions. So I'll catch you all next time. Good luck studying.